Hi, today we're going to talk about experimental and theoretical probability. Theoretical probability is what you expect to happen. It's where the calculations come into play, but experimental probability is what actually happens. And sometimes different factors affect what happens in the experiment, and so we're going to see what that looks like in a math problem. So for example, if you flip a coin, when you're asked to find the probability of heads, you're just saying, in theory, what's the probability of getting a heads? Well, there's one head out of two total outcomes. There's heads and tails. So you have a 1 out of 2 possible outcomes chance of getting a heads. Now, same thing's true for tails. There's only 1 tails on a coin out of 2 possible outcomes. So you'll have a 1 out of 2 chance of getting a tails. Now that doesn't mean that you're always going to get a heads 50% of the times and a tails 50% of the time. So I actually have a coin right here, and we're gonna do an experiment. We're gonna flip it 10 times, and we're gonna see experimentally what's the probability of getting a heads and what's the probability of getting a tails. So the first time, you've got a heads. You can fast forward this part if you are watching this and you don't want to watch me flip it 10 times. Tails. Heads. Heads. Tails. Heads. 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 Tails. Heads. Okay, so we conducted our own experiment and we flipped a coin 10 times. Now, out of these 10 times, we got a heads 1, 2, 3, 4, 5, 6, 7 times we got a heads. So the probability of getting a heads in our experiment is actually 7 out of 10. Could say 70% if you'd like. Probability of getting a tails, well, we got tails 3 times, so it's 3 out of 10 chance of getting a tails. The experimental and the theoretical in this case were different. Now, let's say that we have a bag and we've got some marbles in it. We have 5 green marbles, 2 red, and 3 blue marbles in here. Now, theoretically, the probability of getting a green would be 5 out of 10 because there's 5 green out of 10. Probability of getting a blue is 3 out of 10. And probability of getting a red is 2 out of 10. Now that's in theory, that's theoretical. That would be in a perfect world if everything lined up perfectly. But we know in experiments, different things can happen. You never really know what might happen in an experiment. So in an experiment, we're not going to go through the experiment. I'm just going to tell you what the outcomes were. We had 15 total draws. We did replace the marble in between each time. So every marble had an evenly likely chance each time. And the green was pulled 9 times, the blue was pulled 3, and the red was pulled 3 times. Now, the question is, which color had an experimental probability closest to its theoretical? Now, we can't compare them as they are because this is out of 10 and this would be out of 15. So we're going to have to set up fractions and compare the two. So here we have 9 out of 15 gets us the green. Here we have 3 out of 15. And 3 out of 15. Now we need to compare the two. Now just because we got 3 blues in our experiment and we have 3 blues in the bag, that does not mean that that's going to be our answer. There are 15 draws here, and this is out of 10, so they're not out of the same proportion, so we can't compare it that way. The best way we can compare it is by turning these into percentages or decimals and comparing that way. So 5 out of 10 is 50%, 3 out of 10 is 30%, and 2 out of 10 is 20%. 9 out of 15, you might not know that off the top of your head, and that's okay. Type it into your calculator. You get 0.6, which then turns into 60%. Now 50% and 60% are pretty close, but we're looking for which one is the closest. So let's keep looking. When we put 3 out of 15 into our calculator, we get 0.2, which gives us 20%. 20% and 30% are getting close, but they're still 10% off, just like 50 and 60 were. Let's try our last one, 3 out of 15. Hey, you just did that, so you should know that that also gets you 20%. And oh my gosh, I have actually the same percentage for the probability of getting a red in the theoretical probability and what we did in the experiment. Now, it will not always be the same. The question here is which one's the closest, so you would pick whichever one was super close, and in this case it ended up being the exact percentage. And so here, the red color had the same probability in the experiment and in the theoretical. One last thing to keep in mind, the more trials that occur in the experiment, the closer and closer you become to the theoretical probability. So here, when I did 15 trials, that probably was not enough to accurately represent what's in the bag. If I did 1,000 or especially 1,000,000 trials, I would get even closer to representing what's in the bag. With flipping the coin, if I did 100 trials or 1,000 or 1,000,000, I would get closer and closer to my experiment, accurately representing a 50% chance for each. So the more trials within an experiment, the closer and closer we get to the theoretical probability. Thank you.